Yes, hello out there. This Momentum Mind FS. We have gone to another topic completely in order to bring you more knowledge that will enable you pass your exam with ease. This is a physics question. It says a charge of 1 coulomb. In physics, the charge Q is 1 coulomb. According to here, this charge liberates 0.0033 grams of copper, and that is mass. You see the grams behind it. The mass of copper liberated with this charge is 0.0033 grams in an electrolytic process. How long will it take? How long means you are required to find time. Time is not given. When they say how long, that is about the time. How long will it take a current of 2 amperes? That is, the current flowing is 2 amperes to liberate 198 grams of copper. So this is another mass. Let's call this M1 because we have two masses now. M2 will give you 1.98 grams. How do you go about something like this? It's very simple. Naturally, in an electrolytic process, the mass deposited or liberated at the electrodes during electrolysis is directly proportional to the quantity of charge flowing. Now, from your mathematical knowledge, if you change this to is equals to, you put a constant of proportionality. So that is M now is equals to, we now put a constant ZQ, where Z is what we call the electrochemical equivalent. Now from here, the charge here is 1 coulomb. We want to find Z first of all. Our mass, the M1, this time, M1 is 0.0033 time, is equals to, Z times Q, which is 1. So variably, that means our Z is equals to 0.0033. That is grams per coulomb. Now, they're now asking you that if a current flows for 2 hours, depositing this amount of copper, what time will it take? Then you must understand that the quantity of charge flowing is equals to the current flowing multiplied by time. So from here, we will say M equals to ZQ. Instead of putting Q here, we can replace Q with IT because Q is same thing as IT. So your M now will give you ZIT. Because here we said Q and IT are the same. You have to find the current flowing. So the current now, T, will be equals to mass divided by the electrochemical equivalent times the current flowing. So the time now will give you the mass now deposited is now, that's M2, 1.98 divided by Z, which is 0.0033 times the current flowing, and the current, he said, is 2. So the time now will give you, let us check the calculator and see what we have. Checking the calculator, we said 1.98 divided by, that would be 0.0066. That will give you 300. So the time now will give you 300 seconds. It is as simple as that. From Momentum Minds, until we meet again, bye.